Hello class, welcome to the next lesson in 8th grade Eureka Math. Here we are in Module 7, Lesson 4, called Simplify Square Roots, on pages 35 through 44 of your Module 7 workbook. Now, the key word in this lesson title is simplify square roots. The square roots we will see in this lesson, you will not be able to solve completely, not at this point in your math career, because we've been so far in the last lesson, whenever you had a square root, the square root worked out to be a whole number. The square root problems you're going to see in this lesson often will not be whole numbers, but they can still be simplified. You might not be able to solve it to a whole number. I'm not going to ask you to solve it to a decimal, but you can simplify them, not solve, but simplify. And today is going to come in, your skills will come in really handy if you understand, if your skills include knowing your math facts. So let's get started and I'll show you what I'm talking about. Let's talk about vocabulary first. We have 3 terms today: factor, product, and square root. Now, factor and product you've seen for years, and square root we started talking about in lesson 2. So let's review. A factor is a number multiplied by another number to produce a product. So a factor is a number you multiply to make a product. So in other words, factors are pieces of multiplication problems. Factors are pieces of multiplication problems. The product definition, the result of numbers being multiplied. So the product is like the answer to a multiplication problem. So the factor is like the pieces, and the product is the answer. Now you might be wondering why we're talking about something so basic in this Module 7. It's because you're going to break a product into factors to simplify the square roots. You're going to break a product into factors to simplify square roots. And the final word is square root, a number multiplied by itself to form the original number. And we've seen this before. So it's like the square root of 9 is 3, because 3 times 3 makes 9. So square roots we've been working on. You know factors are the pieces of a multiplication problem, and you know product is the answer. So let's look at what we're doing today. Today we will learn how to simplify square root problems, not solve, simplify the square root problems when the square root is not a whole number. So today you are probably not going to see the square root of 9. You might see the square root of, I don't know, 19 or 39 or 59. I don't know. But we're going to see, but the answer is not going to be a whole number. We're not going to solve them, but I will show you how to simplify them. So some notes for you to look at. The square root of 36 equals 6 exactly, because 36 is a perfect square. You know some perfect squares like 36, like 4, like 9, like 16, like 25, like 49, like 64, and so on. Those are perfect squares because the square root is a whole number. But the square root of 72 is not a whole number. So the answer is not a perfect square. So it's not a perfect square. So the answer is not a whole number. Like the square root of 64 is 8. And the square root of 81 is 9. So the square root of 72 is going to be in between 8 and 9. It's a decimal in between 8 and 9. Because 72 is between 64 and 81. So if you have the square root of 72, how do you simplify it? Well, to simplify it, what you do is you think of 72 like a product. 72 is a product. And what your goal is to think about 72 And how do you get a perfect square out of 72? How do you get a perfect square out of 72? What factors can you make where one of them is a perfect square? And for 72, I think of 36 times 2, because 36 is a perfect square. So I think 72 is a product, and 72 is 36 times 2. 36 is a perfect square, which means I can simplify the 36 part. I cannot simplify the 2 part, but I can simplify the 36 part. So I do the square root of 36 times the square root of 2. I break it into 2 square roots. I take the square root of a product and I turn it into square root of factors. So I have a product here and I have factors there. That's why they're in our vocabulary list. Instead of doing the square root of a product, I do the square root of factors. And one of the factors is a perfect square. So the square root of 36 is 6, and the square root of 2 I cannot simplify, so I leave it alone. So the square root of 72 equals 6 times the square root of 2. This is simplified. Not solved yet, because like I said, it's going to be some kind of decimal. But at least it is simpler now. I pulled the 36 out, and I separated the square roots. And the reason I pulled the 36 is because that is a perfect square. We're going to practice this quite a bit. Let's go to page 35 and see what kind of opening exercises they have for us. Here we go. What does the square root of 16 equal? Well, if you have your chart next to you, or if you have it memorized, you know the square root of 16 is 4. What does 4 times 4 equal? Well, 4 times 4 is 16. Part 3, does the square root of 16 equal the square root of 4 times 4? Yes, because the square root of 16 is 4, and the square root of 4 times 4 times 4 is 16. Square root of 16 is 4. Yes, they are equal. Okay, let's look at part B. I think they're trying to make a point here. Let's see if we can figure out what point they're trying to make with this. What's the square root of 36? Well, that's 6. What does 6 times 6 equal? 36. Does the square root of 36 equal the square root of 6 times 6? Well, the square root of 36 is 6. 6 times 6 is 36, so I get 6 equals 6. Yes. Okay, I think we might be getting close to their point. We're just getting a lot of the same thing, and yeses and yeses and yeses. What is the square root of 121? That's 11. What does 11 times 11 equal? 121. Well, does this equal that? Well, the square root of 121 is 11. 11 times 11 is 121, so I get 11 equals 11. So, yes, that's the same. Okay, one more. Let's see. Square root of 81 is 9. 9 times 9 is 81. Does the left equal the right? Well, this side is 9. Let's simplify inside the square root. That's 81. So I get 9 equals 9. Okay, so what they're trying to tell us is that it's the same thing. It is the same thing if you take a product or if you take the factors. So square root of product equals the square root of the factors. So let's write that down at the top of the page. I'm going to write it down. So the square root of a product equals the square root of the factors. The square root of the product equals the square root of the factors. So you are allowed to change the product into factors to solve. So the square root of a product equals a factor. We saw this here. 16 equals the square root of 16's factors. The square root of 36 equals the square root of 36's factors. The square root of 121 equals the square root of the factors. Square root of 81 equals the square root of the factors. So the square root of the product equals the square root of the factors. And we can use this to simplify square roots. So rewrite the square root of 20 using at least one perfect square factor. So the square root of 20. Now what I'm thinking right now is I'm thinking of my 20 factors, and I'm thinking of, okay, what factors have a perfect square in them? Because I want a perfect square. I want a perfect square factor so that I can simplify. Well, let's list the factors of 20. I know 1 and 20 make 20. No perfect squares. I know 2 and 10 make 20. Those are not perfect. Well, 1 is a perfect square, but it doesn't get simplified. 2 and 10, not perfect squares. 4 and 5. What about 4 and 5? 4 is a perfect square because 2 times 2 makes 4. So instead of doing the square root of 20, I can do the square root of 4 times 5. And remember this, like I told you in your notes, instead of doing the square of both of them together, I can do the square root of them separately, like that. And then I know 4 is a perfect square. The square root of 4 is 2. So that is simplified now. The answer is 2 times the square root of 5. Just like that. It is simplified because I think of this like a product. I think it's a product, and I find out what factors have a perfect square. And 4 and 5, 4 is a perfect square. It lets me simplify. Let's do it again, this time with the square root of 28, because 28 is not a perfect square. Square root of 28 is some decimal. So let's think of the products of the factors that make the 28 product. Well, there's 1 and 28, of course, but that will not help me simplify. 2 times 14 makes 28, but we don't have any perfect squares. 4 and 7 make 28, and wait a second, 4 is a perfect square. So I can simplify this. 4 times 7 are factors that make 28. So I'm going to take the square root of them separately. And I know the square root of 4 is 2. And now it's simplified. And I cannot simplify it anymore because 7 is prime, so it does not simplify. So I get 2 times the square root of 7. That is the simplified form of the square root of 28. So the square root of 28 simplified is this. The square root of 20 simplified is this. And it all comes from what we learned and what we saw in A, B, C, and D, that the square root of a product equals the square root of the factors. So there we go. You can also add something that we saw right here, that it is the square root of factor times the square root of the other factor. So you take the product, you turn it into factors, and then you separate the factors just like that. That's what I did right here. If you notice this at the top, which you should pause the video and write down, is the same product, factors, factors separated. Product, factors, factors separated all mean the same thing, and they all help you simplify. Let's keep going to page 36 and see what else they have. Oh, examples. Simplifying as much as possible. We have 50. Now 50 is, honestly, this is going to take practice for you, because finding the right factors to use takes practice. You might think 5 times 10 makes 50, but 5 and 10 are not perfect squares. So 5 and 10 will not work. You need to think of other factors that will work. And the more you practice this, the better you get. The more you practice and the better you are at your math facts, the easier this is. So when I see 50 and I think simplify, I think the square root of 25 times 2. Because 25 times 2 makes 50. And then I can do the square root of 25 times the square root of 2. Why did I pick 25 and 2? Because 25 is a perfect square. The square root of 25 is 5. So I get 5 times the square root of 2. And that is simplified. It takes practice, and it all depends on how much practice you have and how familiar you are, because you have to find the best products to choose. Finding the best products helps you, and that it just takes practice. It just takes knowing your math facts. Example 2, simplify the square root as much as possible. We have the square root of 28. I don't know why they picked this example, because we just did this on page 35, but we can do it again. I see the square root of 28, and my factors that I think that pop in my head are 4 and 7, because 4 times 7 makes 28, and 4 is a perfect square. The square root of 4 is 2. So I get 2 times the square root of 7. That's simplified as much as possible. So you can see your goal here is to find the factors that will help you simplify. Find the factors that will help you simplify. How about you try this yourself a little bit with exercises 1, 2, 3, and 4. Try this yourself with exercises 1, 2, 3, and 4. There are 4 square root problems. Simplify it as much as possible. Get it as simple as you possibly can. And then, so pause the video right now. Try your best to simplify, and then come unpause when you're ready to check your work. Okay, so hopefully you pause the video and you tried these yourself, so that you can see how you did. Remember, the trick is finding the best factors. So like for square root of 18, I think of 9 times 2 makes 18. Why did I pick 9 and 2? Because 9 is a perfect square. So I can split the square root, and I get 3 times the square root of 2. Does the same thing. The 9 and the 2 split, because those are factors of the product 18. I split the square root. I solve the square root of 9, and I just keep that one, and it's simplified. It's not solved all the way, but it is simplified. I can do the same thing with 44. For 44, I think of 4 times 11. Because I know 4 is a perfect square, and I know 11 is prime. So that gives me the square root of 4 is 2, and the square root of 11 just stays that, because that cannot be simplified anymore. That is simplified as much as possible. Now for number 3, you might have tried this, but then you might have realized something. Hopefully you realized something, or you looked at your square root chart and you said, wait a second, 169 is a perfect square. 169 is a perfect square. So this is just equal to 13. That's a whole number. I did tell you that most of the problems you'll see cannot be simplified. I did not say all of them could not be So this one's a tricky one. Maybe you spent some time trying to break this into pieces. But if you break it into pieces, you still get 13. It's 13 exactly. But that's simplified as much as possible. Number 4, however, is not going to be a whole number. But when I see 75 and I think of perfect square factors, I think 25 times 3. Because I know 25 is a perfect square. In fact, the square root of 25 is 5, so I get 5 times the square root of 3. Those should be your answers. That should be your work. Hopefully you got all those and you simplified them as much as possible, finding perfect square factors and sometimes one not perfect square factor that you just have to keep because we're simplifying, not solving. A couple more examples. Let's keep working a little bit. So hopefully you got those. Let's try the next page. I think this is the last page of our exercises. We have example 3 and we have example 4. And it looks like they're making these a little bit more complicated because these are not numbers where you have a lot of, you have not really memorized all the factors of these numbers. Like for these, you could probably think and make the factors of 18. You know the factors of 44. You know the factors of 75. You probably do not know the factors of 128. I'll be honest, I do not know the factors of 128. So this is going to take a little bit more work. So let's try breaking this up into other factors. So when I see 128, I'm like, okay, what can I break 128 into? Well, I know that 4, I know 4 goes into 12 and 4 goes into 8. So I know 128 is 4 times 32. Okay, but can I break 32 into anything? Well, I can. I can do 32 because 4 is a perfect square. Can I get another perfect square? I can do, well, 32 is 4 times 8. And then I know 8 is 4 times 2. So I used simpler factors. So I could have done this faster if I just said, well, you know what, 128 is 64 times 2. But I didn't want to do it that fast because I wanted to show you that you can just use small. Well, let's do this. Let's break this. I have the square root of 4 times the square root of 4 times the square root of 4 times the square root of 2, which is 2. Square root of 4 is 2. Square root of 4 is 2. Square root of 4 is 2. Square root of 2 cannot be simplified. 2 times 2 is 4 times 2 is 8. So I get 8 times the square root of 2. That's our simplified answer. That's as simple as it gets. Now, was that the fastest way to do it? No. There is a faster way to do 128. But you really have to know your math facts and you really have to recognize things. Some people might say, well, wait, 128 is 64 times 2. And I can break the square root to the square root of 64 times the square root of 2. And I know the square root of 64 is 8 times the square root of 2. So I get my answer that way also. It's the same answer. This way is faster, but you have to recognize and see that 64 times 2 is 128. A lot of people just might not see that. They might not know that. You might not even think that 64 times 2 makes 128. But you can do it this way. Or you break it into pieces. Like I started with 4 times 32. Then I broke the 32. Then I broke the 8. And then I solved it. I got the same answer. Sure, this was more steps. But I did it this way because I did not know this one. So you can do whichever way works for you. You are just breaking the 128 into perfect square factors. Let's do the same thing with example 4, the square root of 288. Now you're thinking of the 288 and you're like, I don't know. What is that? Well, if you don't know if you don't know the fastest way, like this one, if you don't know the fastest factors, just pick any factors. Just pick whatever you want. Like a good strategy might be, well, 288 is an even number. So you know how you break even numbers, you just take out a 2. So what times 2 makes 288? So I have 288 product. 2 is one of the factors. What's the other factor? Well, to find the other factor, you can just get out your calculator and you go 288 divided by 2 and you get 144. So you just take 144 times 2. Well, that helps. That helps a lot. Because all you had to do was say, okay, wait, 288 is even. So let me just get the 2 out. Let me get the 2 out. In fact, that's a great strategy if you're ever stuck. Just pull out the 2. It works for every even number. Just take out the 2. If you take out the 2, you will probably get something that you can use. Like right here, I can use the 144. Because the square root of 2 I cannot simplify. But the square root of 144 is 12, because 12 times 12 makes 144. So my answer is 12 times the square root of 2. So this is a good strategy right here. If it's even and you're stuck, pull out the 2. If it's even and you're stuck, if even, use a factor of 2. Use 2 as a factor. If it's even and you're stuck, use 2. If it's even and you're stuck, use the 2. Okay, that's one of your factors. If it's even and you're stuck, one of your factors is 2. So let's practice some of those. You're going to practice on exercises 5, 6, 7, and 8. And there are 4. And some of them, you're like, I don't know those factors. But look at all of them. 8, 0, 0, 4. All of them are even. So if you do not know them and you get stuck, use the 2. Use the 2. So pause the video. Try exercises 5, 6, 7, and 8. Use 2 for one of your factors. And unpause the video when you're ready to check your work with mine. Okay, so hopefully you went through 5, 6, 7, and 8, and you looked at these and it says, okay, let's simplify. I have the square root of 108. Now, some people know your math facts really well, and you might have said, wait a second, 108 is 9 times 12, and you might have used that. Other people might have just pulled out the 2, and that's perfectly fine also. Okay, so I'm going to do this both ways. I'm going to break 108, the product, into 9 and 12 factors, and then I'm going to break it into 2 and 54, because some people might have said 9 times 12 makes 108. Some people might have said 2 times 54 makes 108. Some people might have said something else. I don't know. But let me do it both ways to show you that as long as your factors are good, you'll get the same answer. So this one I'm not done breaking yet because 12 is 4 times 3. Now I can stop. I get the square root of 9 times the square root of 4 times the square root of 3. That gives me 3 times 2 times the square root of 3, because the square root of 9 is 3, square root of 4 is 2, and that cannot be simplified. So this gives me 6 times the square root of 3. Same answer. If you did square root of 2 times 54, you probably had to keep breaking 54. So you did square root of 2. How do you break 54? Well, pull out the 2 again, and you get 27. And then you need to break the 27. You get 9 times 3. And then what you want to do is you want to put the 2's back together, 4 times 9 times 3. Because then you get the square root of 4 times the square root of 9 times the square root of 3. That gives you 2 times 3 times the square root of 3, which is 6 times the square root of 3. Same answer. So you can see it's the same answer. The fastest way to do this, and I don't know if anybody saw this, you could have just done 36 times 3, and you could have simplified it the fastest way. If you did 36 times 3, you get the square root of 36 times the square root of 3, which is 6 times the square root of 3. So you can see that you can use whatever factors you want. Some people might have seen 9 times 12 and got it this way. Some people might have got 2 times 54 and got that. Some people, the fastest people, might have done 36 times 3 like that. But that's 3 different ways to do this. 3 different ways. So it works out really well. So let's try another one. Let's check your work for number 6. Now, when I see 250 and I'm thinking perfect squares, I'm probably just going to break this into 25 times 10. Because 25 times 10 makes 250. And that's where I'm just going to stop. Because I know that that's the square root of 25 times the square root of 10. And so I get 5 times the square root of 10. That's the answer you should have got. Maybe you did not do 250 times 10. Maybe you did 125 times 2. And then you had to do 25 times 5. But whichever method you used, this is the answer you need to get. Whatever factors you pick, this is the simplest form. That is as simple as it gets. That's what you should see on your paper. If you did not get this, check your factors and see if you could have picked something else. Or ask me for more help. I'll talk you through it. Now for number 7, exercise 7, the square root of 200. For the square root of 200, you need to think about what factors will make 200. And for me, it's one of those things where I see this, I see 200, and I think that is 100 times 2. 100 times 2 is what I see. And I like this one because 100 is a perfect square. So I do the square root of 100 times the square root of 2. Remember, I told you, if you get stuck, pull out the 2. Pulling out the 2 was the fastest way here because the square root of 100 is 10, and the square root of 2 just stays there, and that's the simplest answer right there. That's what you should have gotten. Maybe you didn't do 200 is 100 times 2. Maybe you did 50 times 4 or something like that, 25 times 8. Whatever you did, if you simplify enough, everyone gets the same thing. Okay, what about the weird one? What about 504? How do we simplify 504? Well, remember what I said. If you get stuck, pull out the 2. Pull out the 2. So I'm kind of stuck on this one. So what I'm going to do is I'm going to pull out the 2. And if you do that, you get, I think it's 257 times 2 makes 504. No, not 252 times 2. I'm sorry, 252 times 2. So I get 252 times 2. Well, that's still not simplified enough for me to work with. So let's pull out something else. Let's pull out another 2. Let's do 252 divided by, let's do 252 divided by 2, and I get, so let's break it again and get 126 times 2 times 2. This 2 stays and 152 breaks. I still don't know 126, so let's break that into, what is that, 63? 63 times 2 times 2 times 2. 63 also breaks because I can divide by 3. I can divide by 3. You can see how long this is taking me. You don't have, so there is a faster way to do this, but that's okay. Let's do 21 times 3 makes 63. Don't forget to keep your 2's. Let's move it up here because I'm running out of room. 21 is 7 times 3 with this 3 and my 2's. So that is broken down as much as possible into primes. Now I have to figure out, okay, how do I simplify this mess of numbers? Maybe you spent some time working on this, because I'm spending some time working on this. Well, 3 times 3 makes 9, which is a perfect square. So I'm going to put these 3's together to make a 9. And I'm going to put these 2's together to make a 4, because 4 is a perfect square. So the 3's go together, make 9. 2's go to make, they're going to make a 4. I keep a 7. I keep a 2. So I'm going to pull out the 9, pull out the 4, and I'm going to keep the extra 7 and the extra 2 together. That gives me 3 times 2 times the square root of 14, which is 6 times the square root of 14. That's your answer. That was a lot of work to find that answer. I had to pull out a lot of 2's, then I started pulling out 3's, and then I had to combine them again to find my perfect squares. Then after I had my perfect squares, I still had the square 14 inside the radical. So it's understandable if you did not get number 8. But hopefully you understand how I got number 8. Just by finding factors that could work and make perfect squares. That's the big idea today. Find factors that can make perfect squares. Find factors that make perfect squares. Because that's how we simplify. Sometimes it'll be like page 36, where the factors are easy to find. Where the perfect square factors are easy to find. Sometimes it'll be like page 37, where the perfect square factors can take a little bit of work, can take some work. But I think if you do the work, if you don't give up, if you persevere, you can do this. Let's check your independent work. Lesson summary is on page 38, just showing you how to find the factors that work. Exit ticket is 39. Let's talk about that last. The homework helper. Some extra examples might really help you on this. So you have some extra examples on page 41 and on page 42 to show you how to do the work in your problem set, how to practice finding perfect square factors. Your problem set is on page 43, and I believe page 44. Yes, page 43 and 44 are your problem set. Find the perfect square factors. Find the perfect square factors to help you simplify. And then it's going to ask you to kind of combine this lesson with lesson 1, where we learned the Pythagorean theorem. So you're going to use the Pythagorean theorem for 6, 7, 8, and 9. So you have triangles. You have to find the missing side using the Pythagorean theorem and square roots. So this is combining your knowledge from the first 4 lessons in this module in the problem set. If you get stuck, remember to ask me for help. I want to help you. I will help you. Also, remember my answers are online, so you can check your work with mine. That's perfectly fine. And then when you feel confident after the problem set, go back to page 39, which is the exit ticket, where they ask you to simplify 4 square root problems. Starting with the square root of 24, which is probably the easiest one, moving up to the square root of 2,420, which might take you some time. But keep going at it. Try your best at it. I know you'll do well. As always, ask me for help. And as always, I'll see you for the next lesson.